Hello there, folks. Hey, this is Joe Ozu here. Hey, in this little demo, we're going to take a DIO card on the back of a Graphite HMI, and we're going to see how fast of an input signal it can see to take a measurement. So in this example, we actually have a customer that has a float meter, some kind of a wheel that gives a pulse every time some 3 gallons or something goes by. So the question is, how long does that pulse need to be in the on state for the DIO card to actually take that measurement? And for this example, I'm actually going to use a Turk FEN20 product running a simple RG code that's going to just create my square wave based on what type of time I'm going to put out. So for instance, if I go ahead and put in here a speed, well, let me show you something here real quick here, team. Let me get away from this. I'm using the DIO card that's on the back of my Graphite HMI, this particular card here. And I'm using the relay one, but that doesn't matter because the inputs are all solid state. So I'm using this particular card, and I have wired on this card. My input is going to input 1 or 2 on this thing. I have this number 2 for this test. But anyway, I'm doing a sourcing input. So I've got the V minus of here tied to my power supply, and the V plus is coming out of one of the outputs on my FEN20 block wired into here. So that's what I have here. And then on my Crimson database, I've got that card set up all as active high. Not doing anything with the outputs for this, so that's what I have. And I got some data tags mapped to different things in here, so that's no big deal. That's what I'm doing in this example. So let's go ahead and take a look at this and see how it performs. Let me go here to the web server of what I'm using. This is the Graphite HMI. So if I put in a speed of 1000 here, that would mean 1000 milliseconds in the on time and 1000 milliseconds in the off time. I have 2 counters going on here. I've got a trigger counter on the tag for the input. So anytime, let me show that logic so you guys can see that. That's this one right here. If I jump to it, it's tied to this input here. And anytime this guy goes on, anytime input 2 goes on, I am triggering that and doing a count. That's just a local count here on the screen. And that's going to be the count that happens in the Redline HMI on this particular application. And so, and then I also have from the FEN20, I have a counter in there that gives me what the FEN20 shows. So that's going to be what it's putting out. So we're going to try to compare these 2 numbers and see what happens as we make the speed faster, if you will. So back to our little demo. So if we put in 1000 milliseconds here, let me go ahead and start this. And you're going to see that input 2 goes on and off, on and off. So it's on for 1000 milliseconds, off for 1000. So it's basically on for a second, off for a second. And as you can see, the counter in the FEN20 is here, and the counter in the Graphite HMI is right here. So it looks pretty good. Works great there. Let's go ahead and make this 500 milliseconds. Now I have to reset my RG every time. So I'll reset it back to 0. Let me clear our local counter here. Okay, let's put this at 500 milliseconds. All right, let's try it again. And you can see it stays pretty good. Spot on the money. It's half a second it's on, half a second it's off. Perfect, looks good. Let's go ahead and make that a little faster this time. Go ahead and stop this, start it again here. All right, this time let's say we go to 250 milliseconds. So now it's on for 250 milliseconds, off for 250 milliseconds. Reset our counter. All right, let's try it again. You can see it's quite a bit faster, but it's tracking exactly what the FEN20 says. Perfect. Looks good to me. I don't have any problems with that. Let's go a little bit quicker here, team. Let's go ahead and reset our little FEN20. Let's take it down to, say, 200 milliseconds. See what we have here. Reset our counters. All right, let's try it here. Yeah, looks pretty good. Pretty spot on here. Yep, I like it. All right, let's go a step further. Let's go to 150 milliseconds on this next one. Okay, so we'll put in 150 here. Whoops, not that number. Reset our counter. All right, here we go. Yeah, looks pretty spot on. Numbers are tracking exactly the same. That's what I want to see. Great. All right, let's go a little quicker this time. That's 150 milliseconds. Let's take it to, say, 125 milliseconds this time. We'll clear our counter. We'll put on this 125 milliseconds. All right, let's try this. Yep. So if it's on for 125 milliseconds, we're being spot on with our counter. Looks perfectly fine to me. Great. All right, let's go a little further. Let's take it to this time. Reset my counter. Let's take it to 110 milliseconds. Yeah, it looks like it's right on the money. To me, it's tracking pretty good. Yep. The FE20 counter measures the same as the internal counter red line, which works good. Remember, the scan time of red line mostly is 100 milliseconds. So I'm thinking if I get this below 100 milliseconds, then we're going to start to see some weird things. So let me go ahead and reset our little FEN20 again. Let's take it to, let's go to 105 milliseconds this time. Let's do that. Let's reset this. Let's see what happens here. Look at that. So as I went to 105 milliseconds this time we started to see where the FEN20 is counting faster than this. We've already missed some. So I'm thinking that the fastest this could really actually see the input signal would be at 110 milliseconds or greater for the on state. Let me go back here real quick here and reset this guy again. Go back to 110 just for giggles. Reset this. All right, let's see here. 110. I think it stays pretty good. I'm pretty consistent. Now, I don't have much other code running this thing, so who knows how that would bear into this. This is all I'm really doing for this simple test. It's all based on the triggers tab for that particular signal. So that's the other thing. I'm doing this all on the triggers tab for this test right now. I could try something else. I wonder if I could, wait a minute. Let me go ahead and try a little further here. Let me go a little faster than this. Let's say I take it down to, say, 90 milliseconds, really below that 100 millisecond scan time we have. And let's see what this happens. This should really prove it. Let's see. Oh, yeah, you can clearly see that the real pulses are way faster than what the actual card can see here. And so you can tell that it's not reading accurately at anything faster than 110 milliseconds on time. So my theory is with the DIO card, with a barely loaded system here, there's nothing really going on in this thing. Really, you need to have your input signal on for greater than 110 milliseconds. I would probably play it safe and say 150 millisecond on time is what that would need to be on for this thing to actually see that value running. So if you want to see it faster, well, just for giggles, I'll show you. So let me go here, and let's say I really set this thing up for a 10 milliseconds on time. This ought to be incredible. Watch this crank away. So you can see that the pulses are really fast now, and the FEN20 is, or not the FEN, but the DIO card is not able to see that transition from on to off even at that range. So it's seen as constant on. If I make this, there, if I slow it down, it grabs a little bit, but it's, in my opinion, it's not consistent enough. So your input signal has to be on for at least, I'd say, 150 milliseconds for this card to actually be able to read that as a pulse coming across. So if you have a signal that's faster than that, you might need something that's a pulse stretcher or some other part of input. I can foresee in this application that if I had really fast signal, I could use an FEN20 to see that and translate it here as a counter through some RG code, or I could even use what I would prefer, the banner snap signal S15C-B22 would be a very nice product to use for this application. Or you can also use a counter meter from Redline with a 45 chord card in it and have that offset some of that pulses as well to a counter card. Anyway, this is just a quick little demo on the DIO capabilities for the card on the Redline HMI. Again, I think the fastest I would be consistently good with would be 150 millisecond would be what I would do. So that's my theory on this. Anyway, just a quick little video showing that off. Hey, thanks a lot, folks. Have a great day.